on this auspicious day to celebrate 64 years of innovation sway. In the realm of discovery, we find our delight at CSIR Northeast Institute of Science and Technology, where brilliance takes flight. On behalf of Director and staff of CSIR-NEIST, I, Dr. Monty Gogoi, extend a warm welcome to our distinguished guests, esteemed dignitaries, colleagues, and one and all who have gathered here today. Together, we gather here with hearts brimming with pride and gratitude as we commemorate the 64th Foundation Day celebration of CSIR-NEIST. To commence this auspicious occasion, I invite Ms. Sudipta Barua, Project Associate, to invoke the blessings of Goddess Saraswati through a Saraswati Vandana.
या श्वेतपद्माशना या ब्रह्माच्युतशङ्करा प्रथिभिः देवशरणान्विता सा मां पातु सरस्वती भगवती निश्चेयराय पहा तुभ्यं ब्रह्मविचारसा परमा आद्यं जगत्यापिनी वीणा पुस्तकधारिणी अभयदा जडन्धकारपहा हस्ते फाटिकमालिकं निदधति पद्मासने संस्थिता परमेश्वरी भगवती बुद्धिप्रदां शारदा बुद्धिप्रदां शारदा बुद्धिप्रदां शारदा.
Thank you, Sudipta, for that soulful rendition. May I now request Dr. V.M. Tiwari, Director CSIR-NEIST, today's chief guest, Professor Bhupendranath Goswami, SERB Distinguished Fellow, Cotton University, Guwahati, and a former director, IITM Pune. Today's guest of honor, Dr. D. Ramaya, former director, CSIR-NEIST, to kindly grace the dais as we extend our heartfelt gratitude towards them. Thank you, sirs. I now invite Director CSI-NEIST to felicitate our esteemed guests. Sir, may I kindly request you to extend a token of our gratitude and appreciation to our today's chief guest, Professor Bhupendranath Goswami, sir. As a distinguished scholar and a former director of IITM Pune, Professor Goswami's contribution to the fields of academia and scientific research are truly commendable. And we are really privileged to have him with us today. Thank you so much, sir. We are indeed very fortunate to have with us our former director, Dr. D. Ramaya. Sir, I would again request you to kindly felicitate Dr. D. Ramaya, who is today's guest of honor. Thank you for joining us, esteemed dignitaries. Now I would request ER Jayanta Jyoti Bora sir to come up on stage to felicitate our dear director, sir. Thank you, sir. Now I would like to invite Director CSIR-NEIST to deliver the welcome address and set the tone for today's proceedings. Please, sir.
Today, chief guest, Professor B.N. Goswami, very eminent scientist known globally for climate modeling. Professor Ramaya, known to most of you, probably not the younger colleagues who joined recently, the former director of this, our own institute. My dear colleagues, today also happen to have some very eminent visitors from other science laboratory from GST, Professor Gulbaran and team from Indian Institute of Humanism. Very good afternoon and namaskar to all of you. At outset, I wish all of us a very warm greetings on this Foundation Day. The institute, which had rendered its services by doing forefront science in some specific areas and translating the science for the benefit of society. It's a great day for all of us when we gather today to celebrate our 64th Foundation Day, to remember few of our achievements, to realize the fact that this institute, which started at Regional Research Laboratory, had attended its the very good reputation across all over India, within CSIR, outside CSIR, and also internationally. This would not have been possible without the domain services and also the continued and concentrated efforts of colleagues over the decades, which led to several new products which are now in markets, hundreds of, but particularly the high impact factor journal papers, and hundreds of patents which in due course of time likely to be monetized for the benefit of the mankind. At the same time, when we cherish all the achievements made by the institute over the decades, and particularly in recent time when this institute stood at the time of the crisis, testing a large number of the COVID patients and other important contribution during the COVID-19 crisis, we need to very carefully look back and understand that for what we all are here together. Two of the very important things which are also put on the website, and they clearly says that NIST Jorhat will be able to sustainably provide the technology for the sustainable utilization of resources in Northeast. And second, that it will also contribute for the human resource generation, quality human resource generation of the Northeast region. While we are doing very good in both the areas, there are a lot of large number of other possibilities still exist where NIST can take the things forward for not only benefit of the NIST, but also the benefit of Northeast, benefit of the country, and in larger extent, benefit of the humanity. The biodiversity, what we have around, the very diverse, excellent human resource we have within our institute, and the very potential possibility of young generation outside the institute within the Northeast make it all possible that we can aspire for much bigger things than what we have been delivering today. We also understand the limitations of the different kinds, but they all are the part and parcel of each and every initiative when we make any new endeavor in any area, let it be science. I will not take much time talking on this issue, which we will be discussing internally, and would like that all colleagues join together to make our footprint, our footage at the very large scale across the globe. Realizing this fact, we thought that there cannot be better occasion than to have with us none other than uh, Professor B.N. Goswami, who is known for the excellence in many respects. As a professor at Indian Institute of Science, while he produced a very good number of PhDs who are doing pretty well, when he moved at Indian Institute of Geomagnetism, Indian Institute of Tropical Meteorology, IIT in Pune, and I have been always, whenever I used to meet him, saying that sometimes I always try to find out the reason and inspired from your initiative at IIT of Pune, which has brought quantum jump in quantity and quality of the science at the institute. While he had been the leader of the climate research in not only in the country, all over the world, still with very limited resources. As we all know, we have very recently celebrated the Science Day, and Professor C.V. Raman, if we anything remember about C.V. Raman, is designing of his own instrument, experimenting with that, and doing the science of the global standard and fetching the Nobel Prize. In the same way, Professor Goswami, when he returned back to his alma mater, Cotton College, still in very recent past, he could be a catalyst, and majority of you know what catalyst means, as well as initiator for the scientific research which led to the publication in Science journal from India. Very few papers coming from India in the journals like Science, and which are implementable. These are the people who are all inspirations and station in the Northeast. There is no better people, no better person than him to be with us on our Foundation Day, and we really admire and gratefully acknowledge his presence and his readiness for delivering the Foundation Day lecture today and agreeing to be with us. Thank you very much, sir. I wanted to have most of our former directors, incidentally, one of them, Dr. P.G. Rao was here, and Dr. Sastry. And the reason why we wanted to have them are, again, several folds. One is that all of them, in their own way, contributed in uplifting the level of CSIR-NEIST and remain to be ambassador of CSIR-NEIST at the different forums in the scientific arena. The another advantage what I realized while interacting with many of the scientists and technical officers here that we are the youngest CSIR laboratory. You must be wondering what does it mean by youngest CSIR laboratory? And I mean very clear that average age of the scientific staff of CSIR-NEIST is much lower than, or in fact probably the lowest amongst all the CSIR laboratory. In spite of, we are celebrating the 64th Foundation Day. And this would not have been possible without the efforts, without the pain taken by our former directors like Professor Ramaiah or recent time Professor Sastry. We must realize the fact in the present era, it's not easy to make any recruitment. And in a lighter vein, I have been several times told by many of our senior people that when you become director, don't do two things. One is recruitment, another is construction. And both are things are required to construct the institute for which director is appointed. But these are the tricky things, and we owe to all of them, those who could make it possible, and see that we have the good number of young people around. And that was the reason, the contribution made by our former directors. And I thought that we will take their best wishes, blessings, and all the advices to take the institute further forward. With one email and call, all of them positively responded and agreed to come. Unfortunately, because of the other commitments, others could not come, but Professor Ramaiah has been kind enough having his engagement of teaching a student in private university. Still, he could manage few days to be with us. Thank you very much for being with us today. I would again like to remind all my colleagues, senior and the budding scientists, that our strength is our students, project associate, and the younger generation who will make the CSIR-NEIST thrive at the higher level of its scientific excellence. And therefore, we need to look forward for their all contribution, support them, and get them inspired with the such luminaries present. Once again, welcome both of them for being with us and thank them for agreeing to speak and talk with us. Thank you very much. Jai Hind.
Honorable Director, sir, for your inspiring words. It is now time to introduce our distinguished guest of honor. I request Dr. Montu Bhuiya, Senior Principal Scientist, to kindly introduce our today's guest of honor.
Thank you. Honorable Chief Guest of today's function, Professor Upendranath Goswami, Honorable former Director and Guest of Honor of today's function, Dr. D. Ramaiah, and Honorable Director of CSIR-NEIST, Dr. P.M. Tiwari sir, and all my colleagues, administrative staff, students. It is my privilege to introduce Dr. D. Ramaiah sir among you. Most of us know him, so in fact, we don't need his introduction, but specifically for the scientists and technical who joined in last couple of years, I like to introduce him. In a simple sentence, he's one of the men with enormous simplicity. Dr. Dhanaboyina Ramaya obtained his PhD degree in chemistry from Indian Institute of Technology, Kanpur during 1988. He was postdoctoral fellow at the University of Urberg, Germany, and Georgia Institute of Technology, Atlanta. He was visiting scientist of many institutes, including Institute of Pharmaceutical Sciences, University of Padova, Italy, France Atomic Energy Commission, Grenoble, France, School of Chemistry and Biochemistry, Georgia Institute of Technology, Atlanta, USA, Institute of Pharmacy, University of Mainz, Germany, and Advanced Chemical Research Center, University of Barcelona, Spain. He started his scientific career as a scientist at the then Regional Research Laboratory and now CSIR-NEIST Trivandrum in 1988 and was associated with photosciences and photonics, and later on headed its chemical sciences and technology division. And he was the director of CSIR-NEIST from October 2013 to June 2018 before superannuating from the council service. He, in his career, received several recognitions, including Alexander von Humboldt Fellowship, Germany, and Bronze Medal of the Chemical Research Society of India, Professor Anantaraman Memorial Lecture Award, Outstanding Performance Award of NEIST Trivandrum, and he has been elected as Fellow of the Indian Academy of Sciences and awarded Medal of the Material Research Society of India in 2010. He is currently the editor of Photochemistry and Photobiology journal since January 2009 and council member of the Chemical Research Society of India. Dr. Ramaya has published around 90 papers in peer-reviewed international journal, 70 papers in national and international conferences, and he filed 15 national and international patents. So far, 12 PhD and 25 MSc students have been graduated under his guidance, and currently 2 postdoctoral fellows and 12 students are working under his supervision for PhD degree. His current research interests include photochemistry of multi-chromophoric organic systems, design of DNA cleaving agent, molecular probe for nucleotide, and sensitizer for photodynamic therapeutical applications. With these few words, I like to introduce Dr. D. Ramaya sir among you. Thank you. Thank you very much.
Yeah, good afternoon to one and all. Dignitaries on the dais, the chief of our celebrations, Dr. Bhupendranath Goswami, and a fellow, he was my fellow director and again the director of this institute, Dr. B.L. Tiwari. All the members of the CSIR-NEIST family, invitees, and my dear students, ladies and gentlemen, a very good afternoon to one and all. First and foremost, it is indeed a great honor, privilege, and I'm in fact feel homely that I'm a part of this celebration, 64th Foundation Day of our institute. And before I say a few words, but let me also congratulate Dr. Tiwari, having so much of experience. And he was also a director of one of the CSR labs, NGRI earlier. Then also he was the director of another lab, having, expertise in diverse areas. And he has taken the responsibility, the challenging responsibility. I don't know what has really prompted him from the very comfortable place that is in the central part of India to the northeastern part. Maybe I think he will only come, time will tell us is why he must have moved here. But certainly it has to be appreciated. And because he has all the things in his hand, then he could have become director of any of the other institutes as well. And so thank you, Dr. Tiwari, for taking this challenging responsibility. And hope and wish that this institute excels in all its activities, all spheres of its activities, and become a household name in the entire northeastern region and reaches higher heights. And on behalf of all of you and my personal behalf, I think let me wish you the very best and success in your future endeavors, and also the all the future activities that you will be involved, that you will be initiating to take this institute to the next higher level. I have also a couple of points to mention about our chief guest of the function, Dr. Upendranath Goswami. In fact, I think this is his first visit to this institute. That's what I heard. And I think some of my former senior colleagues are not around here. In fact, we had tried a couple of times to bring him here during my time for one of these occasions, but we were not successful. So again, I congratulate Dr. Tiwari for being successful in bringing him here. And also it has provided me an opportunity to meet him and discuss with him. And I think we are indeed looking forward to hear, because we heard a lot about you. And thank you so much for accepting his invitation and being a part of this celebration. So the Foundation Day is we celebrate every year. It's like we celebrate our birthday, right? So for some people, they do celebrate birthdays, and our children are very particular that their birthday has to be celebrated every year. Otherwise, they go, they become sad. But in this occasion, it is also very important that we introspect the way we started with how this institution was, what it has done, and how it has been doing, and again, where we would like to go. And that way, our institute, I think you all agree with me, this is the most unique institute in this region, and which was started way back in 1961 or so. And during the last 63 years, it has really contributed immensely to this region. And this could be done just because of immense contributions of the elder past leadership, as well as all the past and present CSR alumni and members of this great institute. So I would like to pay my respects, thanks to all the members, each and every one, directly or indirectly, associated with this great institute and who have made this institute what is today. It's just because of their contributions. So on this occasion, again, I would like to take, I would like to thank the director and the organizing committee for extending the invitation, for giving an opportunity to interact with you and to visit some of the facilities that were created after I left this institute, and also the laboratories. And most of the laboratories have become model. And again, that yes, congratulations to both to each and every one of you for making this a vibrant place. And you all know that sometime back, I think it was 2015 or 16, there was also, Shimago analysis of our various institutes of India. And I think we ranked fairly well. We had no ranking before that, but then after that, I think we were 15th R&D institute among the various R&D institutes of the country. So we reached that rank, but I don't know the recent analysis, but I'm sure we must be doing much, much better. And so again, congratulations to all of you for making this institute not only the best for R&D, but also for the innovation and also for the products which are highly, have a high impact on the society, and particularly the various products like anti-arthritis, antifungal, and other, herbal medicines. And also there are several, small scale industry based products. There is another, I think, a flagship of this institute is the CSIR project where Dr. Mantu has taken over. Thank you, Dr. Mantu. I think you got my biodata from somewhere. So when I think Dr. Siddhartha has approached me for some brief biodata, because I am part and parcel of this institute, I don't need any introduction, but I don't know. He put some lot of efforts in collecting the data. So, but now my PhD students are more than 27 now. So, but that is anyway, anyway, let that be aside. But thanks for the kind introduction. And, there are, many people who have not only the developed products, passionately involved in the R&D activities, but also brought recently Lawrence to the institute. For example, Dr. Binay Saikia's, Bhatnagar Award, and Dr. Mantu Bayam's becoming the fellow of the National Academy of Sciences, and Dr. Swapnali, fellow of the Royal Society of Chemistry and also the Chemical Research Society of India medal, and also Sanjeev Logan. So all these, of course, I must have missed some of you in various ways for publishing high impact journals, but I think they deserve appreciation. On behalf of all of you, let me extend heartfelt congratulations to each and every one of you who bought Lawrence as an institute. It's very important. And also wish each and every one of you the very best in the future and also success. So I had a small presentation, but now I decided I think it's better that we listen to our eminent, chief guest. In fact, my group, I think, as Dr. Mantu mentioned, our group was mostly involved in, doing research for the light. So as a research scholar, my going to the IIT Kanpur was again serendipity. Again, getting to research activities which are related to the, light. Another serendipity, because, a chemist specialized in organic chemistry, getting into, physical chemistry related aspects and also close to the physics. Light is mostly, loved by the physics, but also, of course, equally by chemists, and mostly the application part of things. So initially, when I started my career at IIT Kanpur, I think some of this is information to the younger generation. So those days, it was only the curiosity-driven research. So if you have an idea, so you wanted to really go and experiment it. But then over the years, I think you all agree with me that there is a paradigm shift. It's not only the curiosity is important, not only the experiment, doing the experiments are important, but it's most important that how these results are going to have the impact on the society. So this is again a point that I'm addressing to the younger colleagues and also to the students. So we have done several aspects related to the light. Fundamentally, we looked at how when a molecule exposed to the light, what it can undergo, what type of, whether it is a cleavage or rearrangement or a product formation, and how important that product, how easily it can synthesize by using light, other than using the various chemicals, because that is again a very important environmental point of view. Then another aspect is that how this reaction is taking place, looking at the transients, characterizing them by using a very sophisticated instrumentations like nanosecond, picosecond, and femtosecond laser. Then we went on to look at not only looking at the fundamental aspects, but then also we looked at how these, such interactions, such chromophores can be utilized as sensor and also for therapeutic agents, in particular photodynamic therapeutic applications. But anyway, I'm not going to show any slides on that. But what I'm trying to say is that particularly the youngsters, when you are initiating a project, it is very important that we ask hard questions. How important that area and what is the status quo and what is the future it is going to be. And when we say it's the future, its impact on society is most important. So when we do something in the lab, and then when we develop a product, then when it goes to the the society and becomes a product and be used by either an industry or by a person as a drug, the satisfaction that we get would be much more. Forget about its economic success, commercial success, but when we say that something we develop and which becomes useful to the society, the satisfaction that goes with that invention will be quite high. So we have to be, feel proud at the end of the day. So it is very important that we ask hard questions, and whatever we do, either it has to be scientifically of high quality or socially highly relevant. And these days, it is not only if you develop something which is only relevant to the Northeast region, but the competition is the global. So it has to be globally competitive and globally important. And these few points I wanted to say is that because this institute is known for its contribution immensely to the society, there were many products developed, many of them have been used, but there is a long way to go to make this institute a household name, and also whatever we do becomes highly important to this region and to the society, not only to the northeastern region, but also to the entire country. Because this is a central institute, and boundaries are not limited. Similar to the science, there are no disciplines. All the disciplines are losing the boundaries. And so on this occasion again, So I think you are all in the festive mood, I am sure, and we are all looking forward to hear our lecture from our chief guest. And I'm indeed very happy to see all of you here again after a gap of couple of years. And I really look forward to the news and success stories from this institute in the years to come. And again, I'm indeed pleased and very happy to be part of this celebration. And I wish each and every one of you the very best in the years to come. And thank you all, and Jai Hind. Thank you.
Thank you, Dr. Ramaya, for your enlightening words. Your insightful speech has truly enriched our 64th Foundation Day celebration. Thank you so much, sir, for accepting the invitation. Now, I would like to invite Dr. Vinay Kumar Saikia, Principal Scientist, to introduce our esteemed Honorable Chief Guest for today's program.
A very good afternoon to all of you. It is my pleasure to introduce our chief guest of today's 64th CSIR-NEIST Foundation Day lecture. Of course, we are indeed also very happy to have two special distinguished persons in our institute. So now for our 64th CSIR-NEIST Foundation lecture, we have today Professor B.L. Goswami. He's currently the SCRB Distinguished Fellow of Government of India at Cotton University in Guwahati. He obtained his PhD from PRL Ahmedabad and did his postdoctoral research institute in MIT and also in NASA. And returning to India, he worked as our director already told, he worked in IIT Delhi, in IIT Bangalore, and in between 1985 and 2006. And then he moved as a director, IIT Pune. He
Dr. Tiwari, Dr. Ramaya, distinguished guests, and scientists on list, my young colleagues, and ladies and gentlemen. I think it is a great honor and privilege to be here with you on this auspicious occasion of Foundation Day of NEIST. I'm really grateful to Dr. Tiwari for inviting me. It is my first visit I was always thinking of coming, but somehow or the other it never happened for the first time. And I'm so pleased to be here with you today. I think I want to offer my greetings and congratulations to you on the very auspicious occasion of the Foundation Day. I think you have a lot to celebrate because I think CSIR-NEIST has come a long way from RRL days to today, and you have achieved a great deal. And I see that there is so much potential to achieve even more. And I think that your the kind of science issues that are relevant regionally but has global importance. You are working with them, but there's so much potential to do much more. And therefore, I think that your what you can achieve is almost sky is the limit. All you need to do is think high. I think you need to think big. And I think I see a lot of young colleagues here. And I think once you think big and connect your locally important problems to the globally relevant science issues, I think this institute is going to go places. And in terms of science, as well as that is translating to socially relevant products. So I'm from this region, and I'm proud to be from this region. But I always when I was looking for doing research at that time, there was no facility in this region to do cutting-edge research. So we had to go out and do get associated with various institutes like IISc or other places. And fortunately, because of that, we could do something. But I was always wondering why from the Northeast region, the nationally, sort of recognizable or internationally recognizable honors and science is not coming out. For a long time, I've been wondering. And of course, I realized there are certain generic issues. But I think that is also changing in time. And as I have not seen, a couple of years ago, we got another prize from this institute, and I was so happy and delighted because this is for the first time from the Northeast Institute. Based on work done here, somebody got a Bhatnagar prize. Many of us, some few Assamese and the Northeast persons got Bhatnagar prize, but we all worked outside in a more conducive atmosphere or facility. But here, somebody worked and then got the Bhatnagar prize. I think it is a remarkable achievement. And I was very proud of it. And of course, things are also changing because I think now I can see that many of young scientists are beginning to get recognition from academies. And IIT Guwahati is making a big difference. They have also many scientists work done here is getting recognized as the academic fellows and so on. So things are changing and you have opportunities. All you need is think and think big, and big in terms of science. And link what is locally important but globally relevant also in terms of science. So if you can do that, your work will be recognized globally, and therefore more visibility and recognition will come. And the facilities have improved today, and you have now good. One thing that I realized that to really do something good, you need certain amount of institutional support and encouragement. And I can see that people like Dr. Ramaya, Dr. Tiwari have that support that you need, and they are committed to encourage young people, especially they are committed to encourage people in this region for this institute. They have that commitment. So therefore, I think you are in a very good position. All you need is to think big, and I'm sure this institute will really flourish in the coming years, and with more recognition, more visibility, and more products for the society, which are more useful. With that, let me get to my topic today. I want to talk about this sustainable development and sustainability, basically. The reason I want to talk about this is because see, we are all talking about today. I think the sustainable development is a buzzword. Everybody talks about it, but nobody does anything about it. And I think that is where our problem is. Why do we have to talk about sustainable development? Because the development, and this is the population growth and industrial development has led to the climate change crisis. And the climate change, because of that, we have realized that we cannot continue to do the same kind of development. We need something called sustainable development. Now, what is sustainable development? So we recognize that we have to solve the climate change problem to have a sustainable development. And that is why we have talked about and found what we need to do. And in Paris Agreement, we have come up with about 17 sustainable development goals. So we have all that in there. We recognize that. But what we have seen is that we have not done anything about it. Instead, we are actually doing the reverse. In fact, perpetuating the climate change problem. So therefore, sustainable problem is a big problem itself. Question is sustainable development ever going to be possible? And so this is a question that I'm going to ask today. And what I'm going to do is, I realize that there is no really light at the end of the tunnel, and therefore, unless something very disruptive solutions come along, and we are able to make some disruptive solutions in terms of geopolitical understanding and policy change in terms of developmental model, this problem is not going to be solved. And to achieve that, we need a really public awareness and a sort of revolution coming from young generation. I think without that, so that policymakers will be able to make those policies which will be for sustainable development. Because right now, as I go along, I'll show you that the policymakers also are not sort of able to make those. They are bound by various geopolitical considerations. So that is what I'm going to do. So to tell you what this problem is, why there is a crisis in terms of sustainable development, and what we need to do, and what we are not doing. So let me start with what is the problem. So as you know, this card is for the first time. This is something called the hockey stick. Have you heard about it? Some people have talked about it. This is for the first time. This figure was published in Nature in 1998 by Michael Mann. This is nothing but global mean temperature reconstructed for 2000 years. For the first time, this data showed that this recent change in the global mean temperature, this rapid change, is associated with, very closely associated with the Industrial Revolution. That means that the global climate, these changes in the climate during this period is very closely related to the Industrial Revolution. So that created, for 2000 years, the global mean temperature actually cooled a little bit, and then suddenly in 150 years, it increased more than 3 times or 4 times the sort of the year-to-year variation. This is the variability. The variability is so small, but this change in 100 years is 4 times larger. So that is the change. that is why it is not variability. It is a climate change. The climate change is far larger than the natural variability. And that is why the first time it established that this is a climate change, and it was associated with the Industrial Revolution and the growth during Industrial Revolution. So when this was published, there was a lot of hue and cry because many of the people, especially the oil lobby, was behind this Michael Mann. And so one of the person wrote a very nasty blog, and in fact accused Mann of manipulating data and showing this. So they said, in fact, he very derogatory remark as like a child molester. He changed the data and things like that, something like that, very derogatory. And so Mann took it up as a and filed case against that guy. So that defamation case was going on for 25 years, and during this period, a whole lot of committees have looked at the quality of this data and the authenticity of the data and everything, and established that everything was correct. And finally, in 2 weeks ago, actually, this is a very interesting history. 2 weeks ago, Michael Mann was awarded more than $1 million of this thing from the person who wrote the blog. So, thing is that over this period of last 30 years or so, the science has advanced so much so that there is no doubt that this is a change, a climate change, and this is due to the industrial revolution. So I think that is the main problem. So let me go forward, and then let me tell you how this is this change in the last 150 years, global mean temperature, how it is compared to the variability, how it is significant, and why it is critical, and has it changed the climate to an extent where there is no possibility of turning back, something called tipping point. So, and it turns out that has seemed to have happened. Now, how did this happen? So if you see, our Earth, of course, is very, very unique in the whole universe. I think so. Until now, we don't know anywhere else that life exists because the climate of the Earth is very, very unique. It is in the right place in the distance from sun, and it has the right kind of greenhouse gases to make the temperature close to what is called triple point of water. And therefore, the water can exist in all the three forms. And this is very critical for life to sustain and strive. But this did not happen. The Earth's climate and environment has evolved over 4.6 billion years, and only this stable climate took place only over the last about 3 million years. Over only the last 3 million years, we have a very stable climate where life could really evolve. But the humans life, intelligent human life history is only about 1,200 years old. And during this time, out of 4.6 billion years, during this time, the humans have exploited the environment so much that now we are causing this irreversible damage to the environment, and possibly a 6th mass extinction is on the way. So it is the human has a distinctly important contribution into this situation today. But we have had this warning for this for a long time, but we did not really pay attention to this. For example, in the early 20th century, Arrhenius, a chemist, he asked this question. Okay, suppose I exploit all the coal in the world and burn it up. How much carbon dioxide I will put in the atmosphere? It will be like doubling the carbon dioxide in the atmosphere. And then he says that, okay, if I double the carbon dioxide, how much the temperature will increase? And he estimated that, by a very crude method, he estimated about 5-degree increase of the global mean temperature might take place. So that was a warning. But for 100 years or so, I think we did not really pay much attention to it until in the 60s, Professor Manabe from Princeton and with his colleague wrote a paper and used the model to actually estimate using all the physics, estimate if I double the carbon dioxide, how much the global mean temperature increase. And he estimated that it will be about 2.4 degrees increase if I increase the present carbon dioxide and double it. And but then the question is, okay, so how much uncertainty is there? Because people will the skeptics will be asking how reliable this estimate is. So there is a committee formed by the American National Academy of Science in USA and Professor June Sani, who was a professor at MIT. He chaired that committee, and they went through a lot of rigorous analysis of what kind of uncertainty we have in this estimate. And it found out that actually the global mean temperature should increase by about maybe 3 degrees plus minus maybe 1.5 degrees uncertainty is there. It will be there because there are many things that we still don't know, and also how the carbon dioxide will change in future to evolve to doubling stage. We don't know what part it will take. So with all the uncertainty, but still these estimates are very close. And until today, this estimate is with all the IPCC sixth assessment report, with all the state-of-the-art models, also give me this more or less same estimate. Okay, so which means that these people in early late 60s and early 70s made this the right kind of estimate, and that is why Professor Manabe was awarded Nobel Prize in Physics 2021. So the science of climate change has been recognized as based on physics, and it is reliable. But we are still not taking any of the necessary decisions to stop this problem. So I had the fortune to work with Professor June Sani at MIT, and I spent a year at GFGL, year of sabbatical with Professor Manabe. So that I was just fortunate to have them. Now let me tell you how big this problem is. Now, if I look at this is the history of global mean temperature over the last 500 million years. So out of this 500 million years, there are a lot of changes in the climate. Big changes happened when there was no human activity, but due to some natural causes. But then from about 60 million years ago till today, the temperature has been cooling down up to about 3 million years ago. And from about 3 million years ago, now the oscillatory climate going between ice ages and warm periods started happening. And in fact, last 1 million years, we had this 100,000 years cycle of ice ages and interglacial and interglacial periods. And now this level is the pre-industrial level. And then today we are somewhere here, a little bit above this pre-industrial level, about 1.5 degrees now. But in the near future, it might go to about 3 to 4 degrees above the pre-industrial level. This is our big problem. Now, why if we go, so one big question of this is that we have to control this global mean temperature to less than 1.5 degrees of the pre-industrial level. Why? This is because you can see this history of what happened to the climate. If I go below more than 1.5 degrees above this, I'll come back to this level of about 3 million years ago. Okay? The 3 million years ago is only when the stable climate started happening. Before that, it was a very warm climate. So the problem is that if I exceed that value, then I will go back to this state in which maybe those feedbacks which keep us into this possible stable climate, glacial and interglacial things happen through certain internal feedback. Those feedbacks will not be able to take place. And if cannot, if the global mean temperature is above a certain high value, then none of this feedback will work, and as a result, other feedbacks will take it to a warm house climate, and that is where we are going to go to a hot house climate like this, and that is the tipping point. So, but we have already crossed that tipping point last year. Now let me show you. So in the last 200 to 2000 years, I have already shown you that it is cooling, and this is a very rapid change. And the rate of change at this period is unprecedented in the last 3 million years. So this is a big change. So this is the first thing. How big is this change? And this change is changing more rapidly in the more recent years. So if I take last 200 years, from 2000 years to 2200 years, this is also changing much more rapidly in the recent years. In the last 40, 50 years, it is increasing it much more rapidly. And in the last 1 year, it remained for, these are like daily global mean temperature records. From now, we have a very big networks of satellite and surface networks, which all combined, it remained more than 1.5 degrees over the most of the last year. So I think this is a big problem. Now, this is associated with warming of the ocean. Now, that makes it even worse because over the last 40, 50 years, the ocean temperature has been, upper level of the ocean temperature is increasing steadily by more than a degree. When ocean 200-meter temperature increases by about 1 degree, the heat content increases tremendous. Now that heat content will then now generate more strong extreme rainfall events and cyclones, tropical cyclones, and that is going to increase the disaster potential to a very high level now. So that is why it is quite a problem. To understand this, you have to have a little bit of understanding of how the climate is actually driven. So to understand that, we have to understand what this climate is and how it is driven. So let me give a very brief introduction to what this climate is. What are the factors that can affect this climate? So climate is essentially what we expect, what is the mean conditions or expected values. On the other hand, on the other hand, the weather is nothing but what you see today, the day-to-day fluctuations. That is weather. But let us concentrate mainly on climate, which is the expected value. And now this expected value is essentially a result of heating that is produced by the sun's rays, sun's energy that comes in. It goes through the atmosphere, and part of it gets affected, absorbed in the surface, and then the Earth re-radiates its own energy. And this whole heat balance is affected by the environment. The environment consists of your biosphere, geosphere, and biosphere, and atmosphere. So all these factors can influence what is the heat balance at the surface. And so therefore, this whole complex environment is very important in terms of the heat balance. And the heat balance is what essentially drives our climate. And that is affected, of course, from the solar radiation is the driver. And solar radiation depends on the geometry of the sun-earth system. And that, because of the geometry, there is a variation in 3 major time scales. One is 100,000, the electricity changes on 100,000 years time scale. So there is a variation of solar radiation in that time scale. Then there is this the angle, the inclination also changes from about 25 to 22 degrees, and that produces another 42,000 year time scale. And there is also a gyration around this axis, which gives rise to a variation of about 21,000 year time scale. So the solar variations can give you some climate variability, but this variation of solar energy at this time scale is very small. So it cannot produce the amount of change that we are seeing today. So this something must have accelerated that change, and that is where the human activity comes in. So let me go to quickly. You can actually make a very simple model of this. Very simple. It is like 12 standard problem. Suppose I consider the Earth as a sphere, and I consider how much radiation it is receiving. a part of it gets reflected back as reflected part, which is called albedo, and then the rest is absorbed. Then the art gets heated up. Art radiates like a black body, and that black body radiation in the long wave is governed by the Stephen-Boltzmann law. So that much radiation is radiated, and this much radiation is received, and this alpha is your reflectivity or albedo. So solar radiation is very important. Input, how much energy is coming from the sun, and how much is reflected back. These two important parameters. Now, reflectivity depends on all these. How much ice is there, how much clouds are there, how much vegetation is there. All that depends on the reflectivity. And Earth's reflectivity today is about 0.3, but 30% gets reflected away. Okay, so but it can change because if you in geological time scale, ocean land distribution is different, vegetation is very different, the reflectivity would be different, and therefore the climate will also be different. On the other hand, this how much of the radiation that is emitted by the Earth, how much of it gets lost to the space will depend on how much is absorbed in the atmosphere. Because in the long wave, the atmosphere has a certain absorptivity that is called long wave transmissivity. So this tau represents the long wave transmissivity. So this long wave transmissivity depends on the constituents of the atmosphere. So and the carbon dioxide, methane, and water vapor. These are gases in which absorb long wave radiation, because Earth emits in the long wave because of its temperature being low. Sun emits on a very short wave, 0.5 micron is the maximum. So because of its high temperature. So as a result, that long wave radiation radiated by the Earth, part of it gets absorbed in the atmosphere and re-radiated back. To balance how much is reflected back, how much is received, then you have to radiate more. And to radiate more, the temperature must increase the surface. That is our basically what is called greenhouse effect. So that is where the transmissivity, therefore, the constituents of the atmosphere is another important part. So if constituent changes, that can also change the climate. So there are three factors that can change our climate. One is solar radiation. Second is the reflectivity or albedo. Third is the constituents of the atmosphere. And it is the constituents of the atmosphere that this solar radiation has not changed very much in the recent 2000 years or 200 years. And reflectivity also has not changed so much, changed a little bit. But what has changed more rapidly is the constituents in terms of carbon dioxide in the atmosphere. And that has changed this infrared transmissivity. And that is why we have now had a different temperature change in the temperature. So suppose I assume that there is no atmosphere, what will happen? So can you guess, any of you? Can you guess? Suppose like moon, for example, has no atmosphere. Then my infrared transmissivity will be 1. So suppose atmosphere, I did not have an atmosphere, I can estimate what will be the temperature in the surface of the Earth. And that will be, if I remove like the infrared transmissivity 1, then it will actually be the equilibrium temperature will be like 255 degrees K minus 18 degrees Celsius. So if there is no atmosphere, the Earth would have been frozen and no life would have taken place. So the atmosphere produces a natural greenhouse effect, which makes life possible. Now, what has happened is that natural greenhouse effect we have changed by adding more carbon dioxide in the atmosphere. So the additional increase in the atmosphere has to be estimated due to the additional amount of carbon dioxide. And that we can do by estimating how much change in the transmissivity will take place due to the addition of so much carbon dioxide. So, and if I know these three factors, I can estimate the temperature of all the planet, and that is why, so we can understand. So these three factors are very important in terms of driving the climate. And what is the changing very much during this period is essentially this carbon dioxide and methane. From observations, we know that the current level of carbon dioxide is like 419 parts per million, and the current level of your methane is about like almost 2,000 parts per billion. So how big are these? To understand that, I can look at what was the kind of variation of carbon dioxide and methane over the last 1 million years. Now, from Antarctic ice cores, people have estimated that what is the carbon dioxide and methane over this. So these are like glacial and glacial and interglacial. So we are currently in an interglacial period. This is the ice ages, interglacial, ice ages, interglacial, and so on. So in this period, the variation of methane and carbon dioxide has been limited. For example, it was between 180 to 280 parts per million in this ice ages and interglacials over the last 1 million years. Similarly, but today we have 423 parts per million. So it's almost 50% higher. So that is the big. So over 1 million years, it is unprecedented, the amount of carbon dioxide that we have seen. So similarly, the methane is also almost 3 times larger than anything that was seen over the last 1 million years. So this level of greenhouse gases is unprecedented in the last 1 to 3 million years. So that is why this problem is very serious. And how does it happen? If you look at the carbon dioxide as over the last 2000 is about 2000 years, the growth of population and the population growth and gross domestic product and global fossil fuel emission and carbon dioxide are very closely related, especially in this period of about 200 years. That is where the population growth exponentially increased. The gross domestic product also, the wealth of the nations increased very exponentially, and the carbon dioxide also increased exponentially. So that is why the level of carbon dioxide today in the atmosphere is related to this population growth and the industrial revolution. So how do we say that it is due to this human activity only? Because there is some natural variability in this system. So there are some other factors also could have influenced this. What are the other factors? The factors could be like aerosols and volcanic aerosols and variations of the other solar variations. So how do I test it? So we can go to a model. Today we have a physical model. So in the model, you can make an experiment where you fix the greenhouse gases in the pre-industrial level and simulate the climate, and then you do add those greenhouse gases and methane as you go along, as observed, and also simulate the climate. It turns out that if I remove the greenhouse gases and the aerosols and keep only the natural variability, the simulated climate do not show the increase in the temperature in this region. So only if I put the observed carbon dioxide and methane and the anthropogenic aerosols, then I get more or less observed change in the temperature is simulated. So this sort of establishes the fact that it is those greenhouse gases and anthropogenic greenhouse gases and aerosols are the primary driver of this recent increase in these. So So this is all related to how much energy we are using, because the emission, it depends, the greenhouse gas emission depends on how much energy we are using. So this energy, in the recent, over these years, in the recent years, this energy usage by our industries has exponentially increased, and 80% of this energy is still based on fossil fuels, and only about 70%, 17 or 20% comes from the green energy. And that is why we are still, sort of putting more and more carbon dioxide into the atmosphere. And how did it sort of came from? It of course came from various different contributors, and mostly the developing countries started producing from the 1850s onwards. But today, there are also many developing countries are also producing. For example, China and India also are contributing considerably. But it is the developed countries like United States. So they started producing. Interestingly, so here is in 1901, how much emission was there? There was just like 2 gigatons of emission every year. Today, we have about 40 gigatons of emission every year for everybody, okay? And out of this, what happens is that when you emit, whatever emission you make, the ocean and the vegetations absorb about, and the land absorbs about 50% of that. And the 50% remains in the atmosphere. Every year, whatever you emit, about 50% remains and builds up. So today that buildup is in the atmosphere is like 2.3 trillion tons of carbon dioxide in the atmosphere. And we are still adding about, this is 20 gigatons every year we are adding. And that is the problem. Originally, it was like 2 gigatons only. After about 1950, only the developed countries like the United States and European Union and produced the emissions. The rest of the countries did not have too much, but now India is producing. But China is the major one. If you see, China has been emitting hell of a lot in the recent years. So India is still not that much, but we are beginning today. We are third emitter in the globally. So we are also contributing, but not as much as China or United States, even though our population is quite large. So this is our problem. So therefore, the problem of creating the greenhouse effect in the atmosphere or climate change is largely due to contributed by the developed countries first, but now slowly the developing countries are also doing it. But unless the developed countries take more responsibility, the developing countries will not take the responsibility because they have started very late. So that is our big issue. So it is a common but differentiated responsibility is what is a very sticky problem. And this is not allowing us to really take a combined and why this is important? Because this is that we have seem to have crossed that tipping point. So if you look at this plot, this during this period of about 1 million years, if I plot the sea level and how much global mean temperature as two kind of parameters, what is seen is that when we it goes into this kind of circular thing, because when in the glacial period the sea level goes down by 150 meters, and the interglacial period it comes up and then goes down. It remains in a stable equilibrium like this. But if it goes to a level, today we are here. If it goes to a level beyond this, then it may be almost difficult. No matter what we do, it might have the feedback which will take it to a hothouse climate, and up to here about 2 degrees, we might still have some chance of bringing it back. But if it crosses 2 degrees, there will not be any chance, and that is the tipping point. and we are almost reaching there today because we have already reached about 1.5 degrees above pre-industrial level. So, and that is the our big problem. And in fact, this has to be in sort of there is something called Earth system boundaries for sustainable development or the tipping point. Because it has to be the different parameters have to be within a certain boundary. So recently, about 150 ecologists, climate scientists, etc., evaluated where are we in terms of these safe and just Earth system boundary. And it turns out that 7 out of these globally safe and just Earth system boundaries, and at least 2 regional safe and just Earth system boundaries in over the half of the global land areas are already exceeded. So this is where our problem is. So we need something done. But what we are doing is currently that to remain this, keep this under 2 degrees, we need to cut down emission by about 25 gigatons every year. But we are not doing that. We are cutting down only about 2 gigatons combined by all these. And that is our big problem. We're still adding more instead of removing. In addition to that, we need to remove because that 2.25,000 gigatons are still sitting in the atmosphere. We have to, even if we cut down, we have to remove a part of that. Then only the future will be secure for our future generation. Because this is a kind of intergenerational justice. See, if we don't do what we have to do today, we are responsible for their future, right? But we have to ensure that their future is secure. And to do that, we have to take decisions today. And that is not happening. That is where our problem is. So, okay. So what is required? We require new innovations. And that is where all of you guys come in. So I think the next science and technology has taken us to this level. All kinds of innovations we have done. We have this industrial revolution, everything. And now AI is coming, automation, everything is coming. And but I think now it is a time where we have to change track. We cannot continue to do the same kind of innovation. We have to concentrate, focus on innovation required to control the climate change and which is sustainable. And so therefore, innovation has to be focused and do all kinds of innovation that will essentially lead to fast and sustainable development. So for that, the emission must be cut. There is no question about it. But we also need a lot of investments to do this innovation. We have to do the research to come up with ideas how we can control this, and that is not happening. Instead, actually, the reverse is happening. People are actually still encouraging fossil fuel use. For example, countries like USA are still undercutting the buying of fossil fuels to the tune of about $600 billion every year. So many countries are, even India is using a lot of fossil fuel, but India may be justified because we have not used in the past so much, so we still need development. So therefore, we will continue. But this is a big problem. But the developed countries are not taking. Instead of that, they are still going for cheap fossil fuel because that is where they can make more money. And that is our major problem. In addition to that, enough money is not coming for innovations, research. In fact, over the last, if you look at the percentage of green innovation, there are all kinds of innovation going on, but the percentage of green innovation has declined from 2012 around. It has started declining. Instead of increasing, it is declining. So this is a major concern. So in addition to that, what we are doing is things like the global conflicts. And as long as these conflicts are going on, it is unnecessary using a lot of energy for destructive purposes and rebuilding. This is just for no reason. And that much of carbon dioxide continuing to will be put on atmosphere, which are almost 80% of that is coming from fossil fuel. That is something that we simply cannot afford. So as long as these conflicts, like Ukraine-Russia war, the West Asia and Israel war goes on, and in other places also, the countries are encouraging in conflicts. The Western countries are encouraging conflicts in Africa and in other places, Taiwan. So as long as this happens, actually, we have a serious problem. So this and all these are based on the model of development that we are following. The model of development is the GDP growth model. So GDP growth model requires this big industries, and big industries uses large amount of energy. So unless we put a cap on energy consumption and change our model of development, we cannot solve this problem. And that is going to be very difficult. So it is, and the GDP growth model is very unlikely to. I mean, it's not going to solve our problem because it encourages inequality, because only a small fraction of the people make more money, and the others, the jobs are not today. Jobs are not created because of automation. So therefore, the money the wealth does not get distributed across the board, and therefore the inequality rises. And therefore, and it is rising. There is inequality index. If you see, it is rapidly rising in the recent few decades, and therefore GDP growth model has to be abandoned. So, but how do we do that? People have actually have come. What is the alternative? In fact, there is alternative. This is a big question. This is a big problem and big question, and the solution is not in sight because of inherent problems. Because who will get the bail? Who will start doing this? So we have to. Some ecological economists have come up with some new idea called degrowth model. So here, what we see is that economic growth you don't as the target for your development. You may not grow much, but still you can still make wealth. But the wealth may not be distributed like big money to some people. So wealth has to be distributed. Something like instead of favoring a few big industries who will invest big money and make big profit. Instead, if we can go into something called the MSME kind of model, where many products will be built, all these different things will be built by individual different small companies, and more people will be, automation will be removed, and more people will work on that in that kind of a model. So there is a way to do that. And of course, the sustainable kind of everything has to be sustainable. For example, one of the things that now urban landscape, now many of the things can be made, the required things can be grown in the buildings themselves, and so that and they can be reused, and sort of circular economy can be. So there are many ideas there exist in this, but how to implement those ideas requires consensus, and that consensus is going to be difficult to achieve. So it is a possible thing, but whether you can do that, because some sacrifices have to be made by some people. And how can you make those sacrifices? Who will make those sacrifices to start with is a big problem. So many studies I have read several studies which are now proposing this, that we have to go away from the GDP growth model and find the degrowth model or the post growth model. We have followed this growth model, but you can see that it's already happening in China. For example, China followed this rapid GDP growth for last 20 years or so, and last 4 or 5 years now they have started going down. So any country, this is an unsustainable way of development. It will crash. Even in India, we are growing today, but I'm sure in the next 5 years, we'll also crash. And this is not sustainable. So we have to figure out what is the best sustainable model of development. And that is where I have my own very simplistic way of thinking is that I think we have to cut down. So a lot of many countries today are spending a lot of money in defense. They're producing all these defense equipment and then go for war and blast them off. And then I think we have to stop that. If we can say 50% of the, if I just made a small calculation, if I 50% of the defense spending of the top 6 countries, it will save $700 billion every year. Okay, and that $700 billion will give me enough money for bring innovations. Today, all these people in the COP28, they could raise only $700 million for research. They could not even raise $1 billion. On the other hand, they're spending so billions and billions of dollars of money in this defense. So yeah, we are doing things that are unnecessary, in my opinion, and things like for creating wealth, we are using energy in a disproportionate way. For example, these are you probably know today cryptocurrency is a new method of making money. So, and cryptocurrency requires what is called blockchain. The blockchain uses a lot of computer power. So much computer power that it actually it is equivalent to emissions of some countries. Okay, and that's what who it benefits only a few people who makes money. So why do we do that? I think we need regulations. And for example, other thing is, AI today, AI is coming into big way, everywhere. But AI is beginning to use a hell of a lot of money and because they also require computer power. So there is a study which says that the generative AI is guzzling water and energy. And this is also now they are going to sort of create some new jobs maybe, but they will also kill a lot of jobs. So this problem, we don't need this. So the development needs to be moderated and sustainable. And that is where we cannot go on doing innovations just to make money. I think this is where, so in conclusion, I will stop. I think this problem has become because the people are. I think the human are quite funny people actually. We recognize that we are in danger, but we do not come together to defend, to create our defense mechanism. On all the less developed species, they will immediately start a defense mechanism. If they find a danger imminent, they will create defense mechanism around them. But humans are not doing that. They are crazily going on perpetuating the problem. And this essentially leads me to famous saying by Gandhi, Mahatma Gandhi said that art has enough for everyone's needs, but it doesn't have enough for everyone's greed. I think we are very greedy people, and this we have to change that. And if we want to survive, we have to change that. But the question is, who will start this first? I think because I can see the problem because suppose India, I said India should start going for a degrowth model. Why will the government do? Because they say that we are already using less compared to the others. I cannot justify that, and the people will also probably then vote him. If you go to that kind of growth model, people will also. So that is where we need to. For people, we need people, the youngsters, to understand this problem, and therefore make policymakers make those right kind of decisions. Help policymakers to make those decisions. Otherwise, we will be responsible for the terrible things that are coming up for the next generation. And that is why I decided to sort of highlight this issue today. In fact, that is true because India, India can, as I said, India is still not producing as much as China and USA, even though our numbers of population is much larger. So you cannot justify to stop it completely. But at the same time, we have a responsibility. Now we also still, for our generation, next generation, we still have a responsibility. So we have to find a solution which is just. And how do we come up with that? Unless some the other people show also some sign. But how do I come up with the global consensus? And our today in an institution like United Nations, there's no global consensus can come because there are few interested parties, veto powers, and nothing can be implemented. So we need a completely a new global geopolitical order, which I think is going to be very, very difficult. So I'm very concerned about the future and worried, but I think we need to sensitize our young generation, my young colleagues here, to go for green innovations and work for green innovation and mobilize public awareness to go for change in our development models. With that, I'll stop. Thank you. Do I, is, huh?
Thank you, sir, for your enlightening presentation. Your expertise and insights have provided us with invaluable knowledge and inspiration. We are grateful for your presence, sir, and the contribution to our event. Let's give him a big round of applause. Now we move on to the significant moment of today's event, the release of CSIR-NEIST annual report for 2022-23. I kindly request Honorable Director CSIR-NEIST, today's chief guest and guest of honor, to release the report.
It is very simple. Someone in the guest house. Yes. Oh, wow.
Thank you, sirs. It is with a great pleasure that I would like to invite our esteemed guest of honor, Dr. D. Ramaya, to launch the CSIR-NEIST Leave Management System portal and an online portal for guest house booking. Sir. We express our sincere gratitude to Sir for gracing this occasion and officially launching the portal. Next, we have a special segment where we acknowledge and appreciate exemplary performance and present the certificate of appreciation to the deserving staff and groups, and also to hand over the trophies to the winning teams and the participants of the Interblock Cricket Tournament of 2024, organized under the aegis of NEIST Staff Club. I request Mr. Rajiv Dekar, Principal Scientist, to take over the next segment of today's program.
Respected chief guest of today's function, Professor Upendra Goswami, guest of honor Dr. D. Ramya, Honorable Director of CSIR-NEIST Dr. V.M. Tiwari, invited guests and CSIR family members. Now it's my pleasant duty to announce the name of the staffs and project staff SRF JRF who have been appreciated in recognition of their constant hard work, dedication, and exemplary services rendered to the institute for the last financial year, that is 2023-24. This certificate of appreciation is presented to acknowledge their hard work and also to motivate them to work in the future coming days. So I'll be announcing the name of the staffs and I request them to come one by one to the stage and receive the certificate from our Honorable Director, invited guests. This time we have chosen 3 research papers with high impact factor. And the first one is iron oxide quantum dots anchored on functionalized graphene, a multimodal platform for sensing and remediation of chromium-6. This has been published in the Chemical Engineering Journal with impact factor of 15.1. And the authors are Dr. Purno Kanta Barua, Dr. Gitasi Dorabdhara, Dr. Priyaksi Bhattakur, Dr. Le Wei Benjamin, and Dr. Manas Ranjan Das. On behalf of the team, I request Dr. Manas Ranjan Das to come to the stage and receive the certificate. The second paper is development of micropollution removal process using thin-film nanocomposite membranes prepared by Green New paper-based interfacial polymerization method. That is also published in the Chemical Engineering Journal with the same impact factor, that is 15.1. And the authors are Ms. Diksha Jadhav, Mr. Sachin Karki, Mr. Bhusam Barbatra Gohai, and Dr. Praveen G. Indole. On behalf of the team, I request Mr. Praveen G. Indole, scientist, to come to the stage and receive the certificate. The third highest impact factor, for which our scientist Dr. Binoy Saikia and one of our research scholar Dr. Sahadev Rava has significant contribution, and that is the reconciliation of energy use despite it in brick production in India and published in National Sustainability with impact factor of 27.6. And the authors are from our list side, that is Dr. Binoy Saikia and Sahadev Rava. And on behalf of the team, I request Dr. Binoy Saikia to come forward and receive the certificate of appreciation. CSIR is also used to encourage the inventor of the patents. This time in the last year, 7 patents have been granted to CSIR-NEIST. And the first patent is an eco-friendly process for the preparation of the vanillin from Ipomoea carnea. And the inventors are Dr. Archana Muni Das, Mr. Manas Pratim Hazarika, and Dr. Monmi Goswami. On behalf of the team, I request Dr. Archana Muni Das, head CSTD, to come forward and receive the certificate of appreciation from our guest. The second patent is IOL observing MATFAIR and a process for preparation thereof. And the inventors are Engineer Jayanta Jyoti Bora, Mr. Pallab Saikia, Dr. T.D. Goswami, Dr. Dipankar Neil, Dr. Dipul Kolita, Dr. Anita Das Rabindranath, Engineer Subodh Chandra Kolita, and Dr. Pinaki Simrupta. I request Engineer Jayanta Jyoti Bora to come forward and receive the certificate of appreciation. The third patent is a soap-cum circle making unit, in which inventor also the engineer Jayanta Jyoti Bora, Dr. Dipankar Nev, engineer Subodh Chandra Palita, and engineer Ajoy Potaki. I request again engineer Jayanta Jyoti Bora to receive the certificate. The fourth patent is a process for preparation of the flexible leather substitute from leather industry waste blended with microbial treated jute fiber. And the inventors are Mr. Pallab Saikia, Mr. Niren Kumar Datta, and Dr. T.D. Goswami. I request Mr. Pallab Saikia to come to stage and receive the honor. The fifth patent is membrane-based process for separation and purification of edible natural dye. And the inventors are Dr. Madan Mohan Bora, Mr. Samiran Bhattakur, Dr. Swapnali Hazarika, and Dr. D. Ramaya, sir. So I request Dr. Swapnali Hazarika come forward and receive the certificate of appreciation from our guest. The next patent is a synergetic pharmaceutical composition useful for the treatment of lung cancer. And the inventors are Dr. Montu Bhaiya, Dr. P.R. Bhattacharya, Dr. P.K. Borua, Dr. N.C. Borua, Dr. P.G. Rao, Dr. Suspita Bhattacharya, Dr. Rakesh Kundu, Dr. Priyadi Chatterjee, Dr. Soma Sil, Dr. Sandeep Mukherjee, Dr. Suman Dasgupta, Dr. Sudipta Mitra, Dr. Seli Bhattacharya, and Dr. Sabir Bhattacharya. And I request Dr. Montu Bhaiya, head of AIDD, to come forward and receive the certificate of appreciation. The sixth patent, patent number 7, that is a process for preparation of blue fluorescence emitting carbon dots from the sub-bituminous territory of high sulfur Indian coals. And the inventors are Dr. Binoy Kumar Soikia, Dr. Tonkeshwar Das, Dr. Sonali Roy, Dr. Bodhi Nazari, Dr. H.P. Dekaburua, Dr. Manavjyoti Bodoloi, Dr. Jimuni Lakor, Dr. Dipankar Neo, and Dr. D. Ramaya. I request Dr. Binoy Soikia, the head of Coal and Energy Group, to receive the certificate appreciation on behalf of the group. Now, this is the time to announce the highest external cash flow earner, that is the ECF for CSIR-NEIST. This time, as of 18 March, we have collected 9.23 crore as the ECF, and the highest ECF earner is Center for Petroleum Research, and it has earned 1.53 crore ECF. Dr. Swapnali Hazarika is the head of the Center for Petroleum Research, and I request Dr. Hazarika to come forward. The service of the technical staff has a very vital role in uplifting the research and development activities of the institute. And this time, 3 persons has been chosen to be appreciated. And the first one is Mr. Atul Bora, Lab Assistant of General Engineering Group. I request Mr. Atul Bora to come forward. Being a staff of General Engineering, Mr. Bora has prepared the wooden stands and the wooden hooks in various departments. Besides, he also provided support to fabricate the particle board. Additionally, he is very actively involved in repairing of the doors, furnitures, windows, as and when required by the divisions of CSIR-NEIST. Next, I request Ms. Deepa Rajbangshi Kasari, Technical Officer of Advanced Material, to come forward to receive the certificate of appreciation. She is very instrumental providing the testing services to various departments and also the outside parties. In the last financial year, almost 5 lakhs ECF has been received by the Advanced Material Group. And apart from she has a pivotal role in supervising the maintenance and operation of the all equipments of Advanced Material Group. A third person, I would like to request Dr. Ajit Goswami to come up the stage. He is from Center for Petroleum Research and recipient of the certificate of appreciation in the technical category. In the last year, he has 5 number of publications, and he is also very active in report preparation of the presentation of his departments, and his all-round involvement in societal, cultural, and sports in CSR premises. Now, coming to the appreciation of administrative staff, this time Mr. Raju Kumar has been selected for the best administrative staff. I request Mr. Raju Kumar to come forward. Mr. Raju Kumar has shown very excellent work and quick disposal of the all works related to tender, NIT, water allocation, parliament and Rajbahar related work, audit reply, housekeeping and maintenance work, especially of general section, work section, and dispatch section. And he is very much visible in administrative work, and that is why he has been credited this certificate appreciation. The next category is the project assistant category. This year, this category was the toughest one to choose. We have received 6 applicants, and out of them, 4 were having almost equal credit in their accounts. So the committee has to go very deep evaluation and giving weightage to various parameters. And lastly, we have selected Mr. Akhil Nanjan Bora, Center for Petroleum Research, for this category. Mr. Akhil Nanjan Bora has 5 number of publications, which first author has 9.5 and 4.1, and range 3 also having a very good impact factor. And besides this, he has also a good book chapter. The next category is Ziara, and Mr. Pathana Bora has been selected as the best Ziara. He has a publication. I request Pathana Bora to come. He has 3 number of publications with 4.9 impact factor in 2 as the first author and the 14.22 as the co-author. In addition, she also possesses 5 number of book chapter, and she presented in the 4 seminars where 2 posters have been presented by Ms. Pathana Bora. Then in SRF category, the incumbent has published 5 number of publications with 2 impact factors of 15.1 and 8.6. And she is also holding 5 number of book chapters, and she is none other than Diksha Jadhav. I request Diksha Jadhav to come forward. She has been nominated as the best SRF for the year 2023-24. Coming to the last part of this certificate appreciation, The best postdoctoral fellow goes to Dr. Banasri Soikia of PSCD. She is having 3 papers with the best impact factor of 5.6, and she also winner of the best oral flash talk presentation award at 7th international conference held in New Delhi. The presentation of the certificates ends here. Now we are coming to the presentation of the trophies and other cups for the NEIST Interblock Cricket Tournament. As we know that NEIST Interblock Tournament has been organized during 27 January to 17 March. Yesterday, last final match was over. So in this, I also request Dr. Sanjoy Deuri and Mr. Prasun Kumar, Vice President of Staff Club, and Dr. Swapnali Hazarika to come to the dais and join our dignitaries while giving away the trophies. First, I'd like to request the captains of the 5 teams to receive their participation certificate. The first is Dr. Biswajit Gogoi. He is the captain of service block. I request Dr. Biswajit Gogoi. If Biswajit Gogoi is not there, any player from the service block can receive the certificates. Any player from service block? This time in the history of CSIR-NEIST, 5 teams have participated in the inter-block cricket tournament. For South Block, Mr. Prasun Kumar is the captain of the South Block. He is there. He can receive the certificate. Mr. Sostap Bhattacharya, he is the captain of East Block. I request Sostap to come forward and receive the certificates. Dr. Rajiv Goswami, he is the captain of Central Block. I request Dr. Goswami to come forward and receive the certificates of the team. Dr. Pankeshwar Das, he is the captain of West Block. I request him to receive the certificate on behalf of his team. Yesterday, the final match is over, and that match was between Central Block and West Block, and West Block has won by 2 wickets, and Mr. Abhijit Das is the man of the match of the final, and he has took 2 wickets in 4 overs, giving only 16 runs, and he has also contributed 11 runs in just 6 balls. Mr. Abhijit Das, he is the man of the match of the final. I request Mr. Abhijit Das to come forward and receive his trophy. In this tournament, some other trophies are also here. The highest run scorer goes to Mr. Sostap Bhattacharya, Senior Technical Officer of his block. He has 150 runs in 6 matches. The highest wicket taker goes to Rakesh Bora. He has taken 11 wickets in 7 matches. Mr. Rakesh Bora, he was so dedicated player yesterday. Just he shown his masterpiece in fielding, and this time the emerging player of the tournament is Mr. Dibbajyoti Soikia from Central Block. He is a trainee student, and he has 43 runs in 7 matches and taken 7 wickets in 7 matches. Mr. Dibbajyoti Soikia, he is the emerging player of this tournament. The man of the series of the tournament goes to Mr. Tosto Bhattacharya again. He has 150 runs in 6 matches and 10 wickets in 6 matches. And for this overall great performance, he has been chosen as the man of the series. He is from his block. Now to announce the runners-up and the champion. The runners-up is Central Block. I request the runners-up team Central Block, Dr. Rajiv Goswami and his team to come forward to the stage and receive these trophies. The players who are present here, they can come forward. Any players from the Central, yeah, please come. And now it is the time for announcement of the champion team, that is West Block. I request all the players of the West Block come forward and receive the trophy from our guest. That is the West Block team. They are the champion of 2024 NEIST Inter Block Cricket. The distribution of the certificate of appreciation and the cricket trophies ends here. Thank you.
Congratulations to all the participants. Before we conclude this memorable event, I invite Dr. Kalyani Medhi, Principal Scientist, to deliver the vote of thanks. Respected participants in the dais and all the members present here in this August auditorium. To mark the closure of the 64th CSIR-NEIST Foundation Day celebration, it's my privilege to be here to propose a vote of thanks. First of all, it's our duty to owe a debt of gratitude to the pioneers, the past and present contributors, known and unknown, whose collective efforts have brought us to where we are today. So we are highly honored by the gracious presence of our chief guest, Dr. Bhupendranath Goswami Danoya, for making it to this function and boosting our morale with his Foundation Day lecture. So your expertise, knowledge, and passion for the climate change issues were truly evident through your presentation. And your lecture has not only enriched our understanding, but also inspired us to delve deeper into the issue and explore new horizons of research and innovation. Thank you, sir. We are deeply obliged by the benevolent gesture of Dr. D. Ramaya, sir, the former director of CSIR-NEIST, for being the guest of honor of today's meeting. As we gather here today to celebrate our achievements and reaffirm our commitments to excellence, we are reminded the invaluable contributions you have made to our institute's journey. Thank you, sir, for always enlightening us with your priceless effort and knowledge. I convey our heartiest congratulations and thanks to our director, sir, Dr. B.M. Tiwari, for his guidance and all kind of support. And we express our deepest appreciation for your unwavering belief in us during organizing this program. I convey our heartiest gratitude to all the retired employees, invited guests, school students, their guiding teachers and authorities who join us during the celebration of this program and being a great pillar of support to the Institute in each and every occasion. The pivotal role
played by the press and media in covering the event is highly commendable, as you were the channel of our thoughts to the society and keeping the peace with the common masses. We acknowledge the presence of our media personnel, Sri Sanjay Hazarika from Neomia Barta, Animation Borua from Joining Ahom, Prashanta Gayan from Ahomia Khabar, Midul Hazarika from Ahomia Potidin, and Raman Saikya from Amar Ahom. I would like to acknowledge the invaluable support we received from our esteemed members in the organizing team for their exceptional dedication and hard work in making the Foundation Day a resounding success. We are ever grateful to the service providers for their untiring efforts and efficacy, which render in a big way for smooth running of this event. Last but not the least, I extend my heartfelt gratitude to all of you for gracing us with your presence and making this celebration a vibrant one. Thank you. And now I request all of you to please stand up for the national anthem. Thank you all once again. Jai Hind. And I request all of you to have, we have arranged refreshment